and science. Dear students, you all know that in yesterday's class, we were focusing on the concept called acceleration in the chapter motion, right? And even we started solving some of the problems as well. Once we shall just go for recalling some important points. As the reason is, as acceleration concept is very important in the examination point of view, and many times they have given the questions on this concept. You all know that the rate of change of velocity of a body, or the change in velocity of a body in the unit time, is known as acceleration. And the acceleration is denoted by the symbol A. The acceleration can be found out by using the formula A is equal to V minus U by T, where V is final velocity, U is initial velocity, and T is time. In this formula, V minus U represents the change in velocity. This physical quantity can be measured by using the unit that is called meter per second square, right? It is SI unit is meter per second square. System of international unit of acceleration is meter per second square. This will also be written as m s raised to the power minus 2. We have come across types of accelerations. One, it may be uniform, and another one is non-uniform. Next, it is positive or negative. When the body is increasing its velocity in the direction of its motion, then what do you say about the acceleration? Yes, it is positive acceleration, right? When a body increases its velocity in the direction of its motion, it is called positive acceleration. Example, when you start moving from your home, then you start walking faster, is it not? Every time you go on increasing your speed. So it is an example for positive acceleration. Even when the body is falling freely towards the ground also, it will go on increasing its speed. It is also an example for positive acceleration. In case of positive acceleration, you all know that final velocity will always be greater than initial velocity. Next, when a body is decreasing its speed in the direction of its motion, then it is called negative acceleration. It is also called deceleration or retardation. Example, when you are riding the bicycle, when you are nearby your home, you start applying the brake. Then due to this, the speed of the bicycle will go on changing, but it will be decreasing. Then finally it comes to 0. Is it not? Here the speed is decreasing. Therefore, it is negative acceleration. In case of negative acceleration, final velocity is always less than the initial velocity, or initial velocity will always be greater than the final velocity. Next, another example, when you take a stone and throw it vertically upward, whether the speed will go on increasing or decreasing, it will be decreasing. So that is, as the speed of the stone will go on decreasing, then finally it comes to rest when it is at a greater height, then immediately it falls towards the ground. Is it not? So it is an example for negative acceleration. Other two types of acceleration are, one is uniform, second one is non-uniform. When the body is moving in a straight line and the speed or velocity changes, if this change in velocity is equal in equal intervals of time, then it is called uniform acceleration, right? If the change in velocity of a body, or when a body changes its velocity by equal amounts in equal intervals of time, then it is called uniform acceleration. Example, a body is falling freely towards the ground. We know that when it is falling towards the ground, its acceleration will be constant, that is 9.8 meter per second square. But speed will be changing. First, when it is falling from the greater height, at the initial stage it will be 0, then 9.8, next 19.6, next 29.4, like this. It will go on increasing. This is uniform acceleration. Next, another one. When you are riding the bicycle in the crowded area, sometimes you will move faster if the crowd is less. If the crowd is more, you will start applying the brake and start moving. So here there will be change in the speed, and this change in the speed, it will be unequal in equal intervals of time. Means when you go for counting it for every 1 second or 1 minute, it will be different. When a body changes its velocity by unequal amounts in equal intervals of time, then we can say that it is non-uniform acceleration. Non-uniform acceleration. So please do remember these points with respect to acceleration. Again, I have been reminding you, in the examination point of view, this concept is very important. And even we solved some problems with respect to acceleration. How many were over? I think 2 or 3. Show with the symbol. 3 were over. Okay. In all the 3, you can come to know that whether we found positive acceleration or negative acceleration. Just to go through all the 3. In all the 3, we have found out only positive acceleration. But yesterday in worksheet, to test your knowledge, I had given you one problem with respect to negative acceleration. Have you observed that? Have you solved? Have you got negative acceleration? Yes or no? Don't know. Oh, okay. Sanvi is responding. Arushi had got negative acceleration? No. Yes, I had expected from some students. It has happened the same. Okay, now let me go for taking the same statement what I have given in yesterday's worksheet. Yes, 3 problems were over. Now I'm going to give you 4th one. Please go for copying this. Right. 4th numerical problem. 4th numerical problem. It is a bus was moving in a straight line. Right. A bus was moving in a straight line. In a straight line. Straight line. With a speed of 54 km per hour. With a speed of 54 km per hour. Amog BM, are you writing? Yes, good boy. 54 km per hour. Full stop. On applying the brakes, whether speed, listen here, on applying the brakes, whether speed will go on decreasing or increasing. No, just observe my gesture, decreasing or increasing. If it is increasing, you can show like this. Decreasing, show like this. Which is? Very good. All of you are very good. It is decreasing. We are applying the brakes so that it will go on decreasing. On applying the brakes, it stopped in 8 seconds. Andre 8 seconds tanka speed decrease ಆಗ್ತಾ ಹೋಗಿದೆ. Finally, it has come to the rest. 8 seconds, full stop. Calculate acceleration. Calculate acceleration. Listen. Hope that you have copied the statement. As the speed is decreasing, whether the body will experience positive acceleration or negative acceleration. Negative acceleration. What is the other name of negative acceleration? I've already given that. It is also called deceleration or retardation, right? And just by going through the statement only, you can tell that our final answer will be negative. Alva? Yes or no? Only. Yes. Good. Very good. Now let's go for solving this. Please go on writing with me. Once you go through the thing, a bus was moving in a straight line with a speed of 54 km/h. Prashant sir, you just allow them. Prashant sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. They allowed.
4.2 meter per
Yes, sir.
Yes, sir.
Sir, please unmute your audio.
Yes, sir. Can you all hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Observe. A bus was moving in a straight line with a speed of 54 km/h. Sanvi, could you tell what does this 54 km/h indicates?
So distance.
Distance.
Speed, sir.
Velocity.
Velocity.
Initial
I love. It is velocity. Kilometer/h is a unit of velocity or speed. It is the velocity, and it is moving with this speed, which means that we can say that it is initial velocity. Initial velocity is denoted by the symbol u. It is equal to 54 km/h. Now observe the other sentence also. On applying the brake, it stopped in 8 seconds. Means after 8 seconds, it will come to rest. When it comes to rest, what will be the final velocity?
Zero.
Zero.
Right? And you can notice that here one quantity is in second, another one is
Kilometer.
in kilometer/h. So units are different. That is why we have to convert 54 km/h into meter.
Meter per second.
Per second.
15 meter per second.
15 meter per second.
It will be disturbance for others. Whenever I give the chance to the particular students, only they will respond. Prashant, how do you go for converting 54 km/h into meter per second?
54 into 5 by 18.
Very
18
good.
54.
Very good. Enough. 54 into 1 km/h is, it is 5 by 18 meter per second.
15 meter per second.
Cancel it. 1 is up, it is 3 is up. 3 5 is up, it is 15. 15 meters per second. Prashant, have you got saved?
Yes, sir.
Okay. Then the final velocity, as the bus has come to zero. Sorry, bus has come to rest after 8 seconds. Final velocity will be 0. You can also write unit 0 meter per second. Next, to change its velocity from 15 to 0 meter per second, it has taken 8 seconds. Alright. T is equal.
Wait, sir. Amok BM. Unnecessarily, you are unmuting your audio. Amok BM.
No, sir.
Mute your audio. What no, sir?
So he has joined it. He has joined today, sir. Just let him take the instructions.
Oh, sorry. Sorry, sir.
A equal to question. Calculation. Please go on writing with me. We know that we have a formula to find out acceleration. It is A is equal to V minus U by T. You may go for substituting. This is equal to where V is final velocity, it is 0. U is initial velocity, this is 15 meter per second, divided by time, it is 8. This is equal to minus 15 by 8 because 0 minus 15 is minus 15. Yesterday when I went through worksheets of some students, they had written plus 15. Be careful while using the sign. 0 minus 15 is minus 15 by 8. Now you may go for cancelling. It is
minus 1.875
Minus 1.
minus
wait.
1
Don't tell, just observe. 8 ones are 8, 7 will remain, it becomes 70. 8 eights are
Minus.
64. 64, 6 will remain, it becomes 60. 8 sevens are 54, sorry, 56. Then you get 4, it becomes 40. 8 fives are 40. This is minus 1.875 meter per second. Is it? Then what is the acceleration of the bus?
Minus
Minus
1.875 meters per second.
1.875 meter per second
Minus
square.
1.875 meter.
Okay, you are right. Actually, you have to tell 1.875 meter per second square. Then you all may be thinking that, sir, why should we not go for using minus? Negative anta ನಾವು ತಗೊಂಡ್ಬಿಟ್ರೆ so it has not moved only ಅಂದ್ರೆ 0 ಗಿಂತ ಕಡಿಮೆ ಆಗುತ್ತೆ ಅಂತ ಅರ್ಥ ಅದು. Here minus sign indicates the bus is decreasing its speed ಅಷ್ಟೇ ಇದು. Got it? Bus is decreasing its speed. This can be indicated by the minus sign. So it is minus minus a, it is negative acceleration. So negative acceleration or retardation or deceleration of the bus is 1.875 meter per second. Clear? When you are writing the conclusion, deceleration is, then you have to write only this much. You deceleration you can write as it is. Therefore, the acceleration of the bus is 1.875 meter per second. Here I write minus of it. Now, hope that you have finished. Let me give you the same type. It has been given in the textbook as well. Right. Same type. Fifth one. A bus decreases its speed. A bus decreases its speed speed from 80 kilometer per hour, 80 kilometer per hour to 60 kilometer per hour in 5 seconds. In 5 seconds. Full stop. Find the acceleration of the bus. Acceleration of the bus. Overall, okay. Rakshita B.
minus 10 by 9 meter per second square.
Wait. It's correct only. Rakshita B. Can you hear me? Can you hear me? Then just by going through this statement, can we say that whether it belongs to positive acceleration or negative acceleration?
Negative acceleration, sir.
It is. It belongs to negative acceleration because the bus is decreasing its speed. Decrease ಆಗ್ತಾ ಇದೆ. So that is why our final answer will be negative. Yes, please go on writing with me quickly. Here, units are different. Here, 5 seconds. Here, kilometer per hour. Hence, I'll go for converting both the speeds in meter per second. A bus decreases its speed from 80 kilometer to 60 kilometer per hour. So here 80 kilometer per hour is initial velocity, right? U is equal to 80 kilometer per hour. Then convert this into meter per second. It is 80 into 1 kilometer per hour is 5 by 80 meter per second. You can cancel it. It is 2 9s are 2 40s are. Multiply 40 into 5. It is 200. 200 by 9 meter per second. Similarly, B is final velocity. It is 60 kilometer per hour. Then even this speed should also be converted into meter per second. 5 by 80 meter per second. Again it is 2 9s are 2 30s are 35s are 150, then by 9 meter per second. Of course, it can be simplified further. But 3 3s are 3 5s are barutte. But I have kept this as it is. The reason is in the initial velocity, denominator 9 is there. In the final velocity, if the denominator 9 is there, calculation will be easier. Then time has been given. Time is, it is 5 seconds. You are going to find out acceleration, right? A equal to question mark. A is equal to question mark. Right. Calculation. You all know that acceleration is v minus u by t, where v is, that is final velocity is, it is 150 by 9 minus initial velocity is, this is 200 by 9 whole divided by time, this is 5 seconds. It is equal to,
Sir, can you take LCM?
simplify numerator. LCM is 9. Numerator 150 minus 200 will be as
Minus 50.
Denominator terms are same. I'll write it in detail. 150 minus 200 whole divided by 5. This is equal to, we all know that 150 minus 200 is minus 50. Minus 50 by 9. In the denominator 5 is there. Take the reciprocal. Reciprocal of 5 is
155.
1 by 5.
5. 1s are 10s are.
10s.
this will be minus 10 by 9.
Meter per
If you want to
second.
express that in decimal form, you can cancel it. Minus 9 ones are 9. 1 will remain, it becomes 10. 9 ones are 9. Again, 1 will remain, it becomes 10. 9 ones are. It will be recurring. Let it be only 1.11 meter per second. Conclusion. Therefore, the acceleration of the bus is minus 1.11 meter per second. 1.11 meter per second square. Hope you have finished. Okay, very good. Now we are moving to the next concept of this chapter. Have you read the textbook? If yes, could you tell what will be the next step? Sorry, next concept of this chapter.
Distance time graph.
Graphical percentage of motion.
Okay, okay.
Graph.
Very good, very good. Yes, students, you all know that with respect to motion, we have come across so many terms. Maybe the distance, displacement, speed, velocity, acceleration, and deceleration. And even we have also come across motion of some objects, it is uniform, some are non-uniform. Based on this, even we have described whether it is constant speed or not, nothing but uniform speed or non-uniform speed, uniform velocity or non-uniform velocity. Similarly, uniform acceleration and non-uniform acceleration. Other than this, even we have also come across positive and negative accelerations. All these can also be represented in the graph. Then you all may be thinking that how it is. So to know about how can we represent the motion of the objects in the graph, just we have to recall the knowledge regarding the graph what we have learned in our previous class. You know that graph, it is one of the concepts. As you have learned, it is used for locating the exact position of a point in a plane, right? Then could you tell the plane that we used for representing or locating the exact position of a point? It is called, what it is? Graph plane. And particular name has been given to this as well. It is also called Cartesian plane. Cartesian plane. Last year only you have learned, you have got one who has contributed the representation of the points in the graph. Who is? He is Rene Descartes. Is it not? Okay, let it be. At least you are very familiar with some of the terms related to graph. Assume that this is the graph plane or Cartesian plane. In this Cartesian plane, I am going to draw the horizontal line and also vertical line. These two will intersect at a point at right angles to each other. So what do you call the horizontal line? It is called
X-axis.
And is denoted as X low, X dash. Then the vertical line is called Y-axis.
Y-axis.
Y O Y dash. Then why should we have the applications of graph other than locating just a point? Even you have taken some of the situations like the number of students who have taken the scores in particular subject in consecutive test that can be represented in the graph by using the vertical bars, nothing but bar graphs. Is it not? Are you following or not?
Yes, sir.
Yes, sir.
Even you might have known that yesterday I had given you the performance graph.
Yes, sir.
In that performance graph, in x-axis, what was taken?
Number of
Marks.
Here, number of students.
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 Okay. So there are two quantities, number of students and the marks. Marks was taken along x-axis, number of students were taken along y-axis. Here marks is constant, alva. 1 mark, 2 mark, 3 mark. But the number of students who secure 1 mark is different from 2 marks, 3 marks, like this. Got it? Anyhow, to represent anything on the graph, we need two quantities. When we come across the speed or velocity, we have two quantities on which it depends. One is distance and second one is time. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ?
Yes, sir.
Yes, sir.
Once I'm repeating, to represent anything on the graph or Cartesian plane, we need two quantities. Here, the speed, it depends on two physical quantities. One is distance and another one is
Time.
Similarly, acceleration also depends on two physical quantities. Arushi, which are these two?
Velocity and speed.
Very good. Huh?
Velocity and the displacement. and,
Velocity and time.
Velocity and time. Velocity and time.
Okay.
Velocity and time.
And time. So from this we can come to know velocity or acceleration can be represented on a graph. And for this purpose, we go for calling the types of graphs as one is dt graph, means distance time graph. Second one is vt graph, means velocity time graph.
Velocity and time.
Just I told the meaning only. But do you know the definition of dt graph and vt graph? If anybody knows, just tell your name and tell the definition. What is dt graph? What is vt graph? If anybody, tell S. If you want to tell. Nobody. Okay.
Motion of an object.
Just observe. Okay. We know that this horizontal line is x-axis. Vertical line is
Y-axis.
y-axis. And this is point of intersection called origin. Is it not? And last year, you have learned, not only last year, before last year, even 7th and 6th also, you have learned how to draw the bar graphs. NP Delva?
Yes,
Very
sir.
long back,
Yes, sir.
around 2 to 3 years back. NP Dena?
Yes, sir.
Yes, sir.
Very good.
Yes, sir.
Yes, sir.
If so, could you tell what type of quantity should be taken along x-axis? Generally, you tell what type of quantity should be taken along x-axis.
Time.
You have to
Time.
understand
Constant
the
value.
question what I have been asking.
sir.
Constant value. Velocity.
ಇದನ್ನೆಲ್ಲ ಬಿಟ್ಬಿಡಿ. Somebody is telling, I think Chetan Raj Jagnur is telling that if the quantity is constant, nothing but independent, that should be taken along x-axis. If the quantity is dependent, graph should be taken along y-axis. Alva? Regarding students' performance graph, ಅದನ್ನ ನೀವು recall ಮಾಡಿ. Okay, here marks. Marks is independent. 1 mark, 2 mark, up to 25 marks. As we conducted the test for 25 marks. Yellow marks different again. 1, 2, 3, 4, 5. And
Number of students.
Score 1, score 2, 5, 10 will be different. Number of students vary ಆಗ್ತಾ ಇರುತ್ತೆ. So it is dependent and is independent. So please do remember, independent quantity should be taken along x-axis. Dependent quantity should be taken along y-axis. If so, students, I'll ask you a simple question. In case of dt graph, which is independent, ಯಾವ್ದು ನೀವು control ಮಾಡ್ತೀರಿ?
Time.
Time.
Time is independent. It cannot be controlled. ಅದು ಸುಮ್ಮನೆ ರನ್ ಆಗ್ತಾ ಇರುತ್ತೆ. But the distance covered by you can be controlled. Now I just covered one meter. I may cover even 2 meters also. Then I may stop. But when I stop, whether the time gets stopped? No, sir. Time keep on running. So that time is independent quantity. If so, Amulya CK, you tell, in which axis we should take time?
X-axis.
In x-axis.
Time should be taken along x-axis.
Independent.
Then distance, it will be varying. So distance should be taken along y-axis. The graph so obtained is called dt graph. Here the definition is the graph which is obtained by taking time along x-axis and distance along y-axis is called dt graph. Is it not simple? Is it not simple? Yes, sir. No.
Yes, sir.
Just to show the thumb symbol. Okay, very good. If so, Manya J. Jain, once you recall this definition, try to tell. Yes, you can. Wait. Yatin or Yashwant, any one of these two can tell. Tell the definition of dt graph.
The distance traveled in the intervals of time.
You are telling the speed. Nan kelta irodu, what is the definition of dt graph? Wait, I'll give chance to others. Wait.
Sir.
Manya, could you tell? Manya A. What is the definition for dt graph? Quicker ಹೇಳ್ಬೇಕು.
The change in position of an object per unit time is called
Speed.
dt graph.
That is the speed. I'm not asking you the definition of speed. I've been asking you the definition of dt graph. Ritika,
Can I tell, sir? Sir, can I tell?
Sir, can I?
First tell your name.
Can I?
Sir, Rakshita, sir.
Rakshita, you tell.
The graph which can travel along with y-axis and time taken along x-axis.
Okay, you have tried your best. I appreciate it. Very good. Okay. Now I'm going to
Sir,
repeat.
can I?
Listen. The graph which is obtained by taking time along x-axis and distance along y-axis is known as dt graph. Got it? You have to recall that with me. Salik, Mohammed Salik.
Sir.
In a similar way, could you define VT graph?
Sir, I will tell.
Wait.
Sir.
Mohammed Salik will tell. Quickly. Quick as possible. Others are also waiting. Okay. I'll give chance to Lakshmi Shri.
Sir, the data which can be represented on graph where x-axis is time and y-axis is velocity.
Very good. That is called VT graph. Excellent. And Sanjana, you tell the definition of DT.
The data which is represent time is represent on x axis and velocity in y axis is called VT graph.
Ah, very good. The graph in which the time is represented along x-axis or time is taken along x-axis and distance is taken along y-axis is known as DT graph. The graph in which time is taken along x-axis and velocity is taken along y-axis, then it is called VT graph. Clear? Now the question is how to represent these motions, that is speed, velocity, constant velocity, non-uniform velocity, acceleration, deceleration, non-uniform acceleration, uniform acceleration. All let us come to know how to represent all these in the graph in today's class. Now please write the side heading. It is graphical representation of motion. Right. Side heading. Graphical representation of motion. Quickly. Side heading. Graphical representation of motion. Graphical representation of motion. Prithviraj, in how many ways motion of an object can be represented in the graph?
2 ways.
Two ways. Yavyadu?
DT graph and VT graph.
One is DT graph, second one is VT graph, right? First one, DT graph. In bracket you may write distance time graph. Distance time graph. Second one, VT graph. VT graph. It is velocity time graph. Velocity time graph. Dear students, one more information. In case of graphical representation of the motion, distance and displacement are to be taken as same. Similarly, speed and velocity are to be taken as same. Okay. Now let's go for writing the definitions of both. Right. First one. We cover today DT graph. DT graph. The graph in which time is represented. Time is represented along the x-axis, and distance is represented along the y-axis. Along the y-axis is called DT graph. Written up. You're writing too slowly.
4 hours.
4 hours. Okay.
Yes, sir.
Lakshmi, still you are writing.
Over, sir.
No, sir, finished.
Finished, huh? Okay. Listen to it. Dheeraj, finished, huh? Okay, good. Dear students, one simple and general question with respect to this. By using the DT graph, distance time graph, could you tell which physical quantity can be described?
Velocity.
Very good. Very good.
Velocity.
Velocity.
DT graph in the velocity. Speed work. Got it? But it should be shown. We have to show that the graph of DT gives velocity or speed. Prithviraj, you are looking right side, then left side, upside, and interestingly, even back side also. You are turning like this and observing. I don't know what it is. Let your complete focus on the class, on the board only here. Observe it. Look. Observe this. Even a copy mode, just keep on observing the board. Here, along x-axis, we have to take distance. Sorry, time. It may be in seconds. Usually we take SI unit. And distance is to be taken
Meters.
along
Meter per second.
and it is to be measured in
Meter
meter. So a graph is obtained. So the general thing point. Graph is a this is the graph. From this graph, how do you come to know the speed, or how do you decide distance to time graph gives the speed?
D by T.
Dear students,
Distance by
in the
time.
previous classes, you have come across the word called slope.
Sir.
Yes,
So we are very familiar with only the
Yes,
word
sir.
called trend, not slope. And we are also very familiar with the soap, not slope. Change your word of slope.
The word, sir.
The slope of the graph in mostly 7th and in 7th standard. Slope of the graph. Okay. So generalize. Here is a slope, slant line. Here is a slant line. You may go for choosing any 2 points on this. I take this as A and this as B. Now let me go for drawing the perpendicular line from B. Got it? And horizontal line from A. These two lines will intersect at a point. I call this as C. Got it? And these two intersect at right angle. What type of triangle is obtained?
Right angle triangle.
Okay, this is perpendicular, and this is also perpendicular, and this is vertical line, and this is horizontal line. And we call this distance, this distance is vertical distance. Vertical distance. And this distance is known as
Horizontal.
distance.
Horizontal distance.
Okay, if you go for taking the ratio of these two, that is the ratio of Prithvi, you're scratching your head like anything. That's not good. Observe. The ratio of vertical distance to the horizontal distance is called slope. That's all. In 7th standard, you have come across the graph. In 7th standard, you have come across Pythagoras property as well. Alva?
Yes, sir.
I learned that.
Yes.
Yes,
sir.
Now,
Yes, sir.
ನಿಮಗೆ ಗೊತ್ತಿದೆ slope is the ratio of vertical distance to the horizontal distance. ಈಗ ನೋಡಿ, it is the graph obtained in dt. If I take the vertical distance, what will get?
Distance.
Now, horizontal distance already ಬರುತ್ತೆ.
Time.
Time.
Vertical distance is this. Vertical distance is distance. Horizontal distance is time.
Time.
This is slope.
Slope.
Look at slope of dt graph. Slope of dt graph. It is equal to vertical distance by horizontal distance. Can I write d by t?
Yes, sir.
Then
Yes,
what is
sir.
d by t?
Distance by time.
Distance by time.
Distance by
Distance by time.
Speed.
Speed.
Speed or velocity. Alva? d by t is
Speed.
speed of the
Speed.
Don't go for sitting with a child. ನೀವು ಅಷ್ಟೇ ಕೂತ್ಕೋಬೇಕಪ್ಪ. Don't go for consolating them. Observe. Distance by time is speed or velocity. Now from this we can come to know that slope of dt gives
Velocity.
Velocity.
dt gives velocity. Understood? Okay. Now please go for drawing this. Draw this quickly. Draw a horizontal line and draw a vertical line. Horizontal line, it is x-axis. Vertical line is y-axis. Have you drawn? With along with the x-axis, you have to write this. Time in bracket, right? Seconds. Without fail, you have to show the arrow mark. Next, along y-axis, write distance. In bracket, you write meter. Show the direction as well. And this is the point of intersection of both the axes. Represent it with O. Graph, just I'm drawing a line. Even it may be the curved line like this also. Even it may be horizontal. Even it may be slant. However it is, just one method ತೋರಿಸಿದ್ದೀನಿ ಅಷ್ಟೇ. Over up. Afterwards, I'll give you the definition of the slope. Now you write second VT graph. VT graph. VT graph. Right. The graph in which time is represented. Time represented along the x-axis. Along the x-axis, and velocity is represented along the y-axis. Along the y-axis is called VT graph. Is called VT graph. If definition is over, go for drawing the graph. Here, x and y axis. Here, this is x-axis and is y-axis. Both will intersect at a point. Call it as O. Then along x-axis, we all know that time should be taken. In bracket, right? Seconds. Along y-axis, velocity should be taken. Velocity. Prithvi, what is the SI unit of velocity?
Celsius. Kilometer per hour.
Meter per
Kilometer.
not kilometer per hour.
Meter per second.
Meter per second is the SI unit. Show the direction as well. And just to draw a straight. Just to draw a straight. Ora. Look here. I'm going to take the graph that is obtained in VT. Straight. I've drawn a straight line. Just look at the board. It is a straight line like this. In this, I go for taking the slope, vertical distance and horizontal distance. That's you tell. What is vertical distance with respect to VT graph?
Velocity.
It is
Velocity.
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 I have told them,
Velocity.
velocity. What is horizontal distance?
Velocity.
Time.
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 Wait, wait.
Time.
It is time. Then what is the ratio of V by T?
V by T.
Acceleration.
It is
Acceleration.
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 From this, can we say that the slope of VT gives acceleration?
Yes, sir.
Yes,
Slope
sir.
of VT gives acceleration. So do remember this one.
Okay, sir.
You written this one, this much. Now write side heading slope. SLOPE. I'll write that there. Right. Slope. Akshay, could you tell the definition of slope?
The vertical distance of and the horizontal distance.
The terms that are used correct, but I want exact definition. Shreya, could you try? Shreya D.
Line which is drawn vertically but
No.
which represent both velocity and time.
The ratio of vertical
The
distance to
ratio.
the horizontal distance.
Very good. The ratio of vertical distance to the horizontal distance is called slope. Right. Right. The ratio of vertical distance to the horizontal distance. To the horizontal distance. The ratio of vertical distance to the horizontal distance is called slope. Just for your knowledge, let me show the slope. You can also draw with it. This a slant line is taken. I'm going to mark 2 points. Let us call them as A and B. Let us find out slope of AB. So for that, you have to draw the horizontal line from A and vertical line from B, both will intersect at a point. Call this point as C, and the point of intersection, at that point of intersection, it will be right angle. Akash P, sit properly, sit upright. Now you write. Okay. Slope of AB. Slope of AB is vertical distance, nothing but BC. Horizontal distance is AC. BC by AC. Overall.
Yes, sir.
Okay.
Yes, sir.
Now, with respect to this, a question was given in the examination. Question in ಕೊಟ್ಟಿದ್ರು ಅಂದ್ರೆ, we all know that the slope of dt gives velocity. Slope of vt gives acceleration. Now we are going to prove these two statements. So in slope only, write these two important points. Right. First point, slope of dt gives velocity. Next, slope of vt gives acceleration. Slope of vt gives acceleration. Now I'll give it as a question. Right. Let me give you the question. It is, one is, the question was asked in the examination. I'm going to give you the same statement. One is, show that distance time graph gives velocity. And second time, prove that the slope of dt is velocity. So write that. I'll give you both the time. Show that distance time graph gives velocity. On another question, prove that. Even you can write show that also. Prove that the slope of distance time graph or dt graph, slope of dt is velocity. Please don't go for writing anything, just observe. Dear students, we are very familiar with the terms uniform motion and non-uniform motion, right? When a body covers equal distances in equal intervals of time, then we can say that its motion as
Uniform motion.
Uniform motion. We're going to consider a body moving with uniform motion. Observe the body. Observe it. Here, I take draw the horizontal line, and this is vertical line. I'll give you time. Okay. Only for the sake of understanding, just I am marking the unit distances. Here, 1, 2, 3, 4, 5, 6. You know that in case of DT graph, we will take distance along x-axis. X-axis. Okay. Time is to be taken along x-axis. Please don't try, just observe. A time like how it talking. This is 0 second, is 1 second, this is 2 seconds, this is 3, this is 4, is 5, and 6 seconds, and go. And so on. Next, here, along y-axis, let me go for taking
Distance.
distance. It is y-axis. Here on right, distance. You know that it is to be measured in
Meter per second.
Meter.
here on right. Okay. It is 2 meter, 4 meter,
6 meters.
6 meter.
8 meter,
8 meter.
10 meter.
10 meter.
12 meter.
12 meters.
12 meter.
Now,
12
I'm going to consider a body moving with uniform motion, which means it covers equal distances in equal intervals of time. Andre, if that body covers just 2 meter in 1 second, in the next second, how much distance it will cover?
2 meters.
4 meter.
4 meter.
4 meter.
4 meter.
4 meter.
2 meter.
First second ಅಲ್ಲಿ 2 meter cover ಮಾಡೋದು. Next second ಅಲ್ಲಿ again 2 meter. Next third second ಅಲ್ಲಿ
2
2
meter.
meter.
2 meters.
Fourth second 2 meter.
Meter.
2 meter.
Answer. In the first second, assume that a body covers a distance of 2 meter. In the next second, it covers again 2 meter.
2 meter.
Now, could you tell in two seconds, total how much distance it will
4
cover?
meter.
4 meter.
4 meter.
4 meter. 4 meter.
4 meter.
4 meter.
Next,
4 meter.
in 3 seconds, it covers
6 meter.
6 meter.
6 meters.
6 meter.
I'm marking it. Let me go for finding these points. You'll get a straight line. The straight line indicates it
Uniform.
is uniform motion.
Velocity.
Please do remember. The graph of uniform motion is straight line or linear. Straight line or linear.
Linear.
Now, here I'm going to take any 2 points. One point is here. I call this point as A, this point as B.
B.
Let me draw
Oh.
vertical distance from both. Sorry,
A.
vertical line from both A and B. Now you can write with me. First, you draw this. Draw this. Hope that you have written the question. No. Question ಬರ್ಕೊಂಡಿದ್ದೀರಪ್ಪ?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
We should write in notebook only, sir.
Yes, in notebook only. Draw X and Y axis. And take time along the X axis and distance along y-axis. Over. Now you will go for marking the points A and B. Mark the point A and B on the line. Any 2 points. Next, draw the perpendicular line from B to x-axis as well as from A to x-axis. Next, draw the horizontal line through A. It should be parallel to x-axis. Over. Similarly, through B as well. Draw the perpendicular line from A to x-axis, B to x-axis. Then draw the parallel line through A and B parallel to x-axis. They intersect at a point. Call this point as C. Just go for darkening the line BC as well as AC. Over. Now below that, you write the information. Right. Consider a body moving in uniform motion. Consider a body moving in uniform motion. Akash, are you writing? Are you writing? Okay. Consider a body moving in uniform motion. Ora. Here, A and B are 2 points on the graph of uniform motion. A and B are 2 points. 2 points on the graph of uniform motion. Next point is observe the board. Let us draw the perpendiculars from A and B to x-axis. So I'll go for naming this. You know, A and B anta tondidve. I'll take this point as C. Sorry, C is already there. This point as B, and this is E. Now we can write draw AD perpendicular to x-axis and BE perpendicular to x-axis. Understood? Understood?
Yes, sir.
Okay, right. Draw AD perpendicular to x-axis and BE perpendicular to x-axis. Next, observe here. We have drawn the line parallel to x-axis through A as well as B. So these parallel lines have intersected y-axis at two distinct points. In order, I'm going to mark these 2 points as F and G. Look here. Now we have to write a sentence like this. Draw FC parallel to x-axis through A. Ritika. Next, another line. Draw GB parallel to x-axis through B. Right. Next one. Draw FC parallel to x-axis through A. Next. And draw GB parallel to x-axis through B. Over. Over.
Over, sir.
Oh, okay. Now just look at the word. Ritika, eating something and listening something. That should not. ಈಗ ನಾನು ಹಂಗೆ ಮಾಡ್ತೀನಿ. ನಾನು ಇಲ್ಲಿ ಏನಾದರೂ ತಂದು ಬಿಡ್ತೀನಿ. I'll go on eating and I'll go for teaching. It seems good, no?
So well, sir.
Observe. Observe. Here we have drawn the perpendicular line from A to x-axis. This line has intersected the x-axis, which means it has intersected time axis. How time only intersect agide? What is that time? We do not know that time. Our time na nanu T1 anta thought. Follow? Just observe carefully. Next, from the point B, we have drawn another line perpendicular to x-axis or time axis. It has intersected at a point. I call this time as T2. T2. Next, observe. Observe. Everybody should observe the board. Next, we have drawn the parallel line to the time axis through A. This has intersected the distance axis at a point. How distance is 1 meter, 2 meter, 3 meter? We do not know that. I take this distance as D1. You may take this as also S1. Okay, in case of graph, we will go for taking distance and speed as same. Sorry, distance and displacement as same, and speed and time as same. Next, one more line drawn parallel to x-axis through B. It has intersected the distance axis at a point. We have called that point as G, and the distance covered at G, it is
S2.
Clear? It's very important.
Yes, sir.
Yes, sir. We have already learned how to take the slope. When you have learned?
One second.
Today.
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 We have learned in 7th only. 7th only. We have recalled that today. Now we are going to implement now. Got it? Learned in 7th standard, recalled just 30 minutes back, and implementing now. Right. Slope of. Yaudu? This is
AB.
AB.
Slope of AB. It is equal to. What is, just to recall the definition of slope? Vertical distance by
Horizontal distance.
What is
BC
vertical
by
D by
distance?
T.
Very good, very good. It is BC by AC. ಹಾಗಾದ್ರೆ my question, just listen. What is the distance from B to C or C to B?
S2 minus S1.
Very good, very good. ಇಲ್ಲಿ ನೋಡಿ ನಾನು ನಿಮಗೆ ಜನರಲ್ ಆಗಿ ಹೇಳ್ತೀನಿ. ಇಲ್ಲಿ ಒಂದು ಲೈನ್ ಇದೆ. Here from here to this, sorry, I take this point as O F G. ಇದನ್ನೇ ತಗೊಳ್ಳಿ. This is 10 meter from here to here. From here to here 25 meter ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. O to F 10 meter, O to G 25 meter. I want the distance from G to F. What is the distance from G to F? 15 meter. How?
25 minus 10.
25 minus 10. 25 minus 10 is
15 meter.
15 meter. Okay. You know, I want the distance from B to C. It is equal to GF. GF, the total distance, it is S2. And up to F, that is up to F, it is S1. So S2 minus S1 is GF. Is nothing but BC. Clear?
Sir.
Yes, sir.
BC by AC. BC place ಅಲ್ಲಿ ನಾನು GF ಅಂತ ಬರೀತೀನಿ. GF AC place ಅಲ್ಲಿ DA ಅಂತ ಬರೀತೀನಿ. Actually, this step is not necessary. Only for sake of understanding, I am writing this. But you should not think that they have taken S2 minus S1 in place of GF and BC ಕೊಟ್ಟಿದ್ದಾರೆ, but FG distance ತಗೊಂಡಿದ್ದಾರೆ ಅಂತ ನೀವು ಅನ್ಕೋಬಾರದು. So that is why I have written GF as well as D. GF is S2 minus S1. S2 minus S1. Next, DE. Anybody want to tell what is
T1 minus T2 minus T1.
T1 minus T1.
My question, could you tell what is S2 minus S1?
S1.
S1.
The distance between the two points.
Wait,
AC.
1 minute.
AC. AC.
Wait.
Yes.
Just to recall acceleration formula. ಇಲ್ಲಿ ನೋಡ್ಬೇಕು ರಿತಿಕಾ, ಶಮಿತಾ, ಇಲ್ಲಿ ನೋಡ್ಬೇಕು. Acceleration formula V minus U by T. What is V minus U?
Final value and initial value.
Initial value.
Very good, very good. If I ask you what is V and what is U, you should tell final velocity, initial velocity.
Change in
I am
velocity.
asking you, V minus U.
Change in
it is
velocity.
Change in velocity.
Change in velocity.
In general, we take this as velocity. Velocity by time. Got it? Even though if it is change in velocity, but it is velocity. And this is S2 minus S1. Change in the distance. Then can we take that as just distance?
Yes, sir.
Yes.
Yes, sir.
S2 minus S1 answer. Yes. And T2 minus T1 answer.
T.
What is S by T?
Velocity or speed?
Velocity.
Velocity. Now, slope of AB is nothing but with respect to which graph? DT graph.
DT graph.
Slope of DT is velocity. Hence, it is proved. Is it not simple?
Yes, sir.
Yes, sir.
Yes, sir.
It is important in
Yes,
the
sir.
examination point of view. Even it is also there in your textbook as well. Earlier, for 9th class also, it was board examination. In that time, they had given. Once you go through this, the question is, show that the distance time graph gives velocity. Means DT graph gives velocity. First, you will draw the graph. Just I'm going to explain this again. Just you will go for drawing the graph And while drawing the graph, you will consider a body moving with a uniform motion. Means it covers it equal distances in equal intervals of time. Hence, it will be a straight line. And in that straight line, we have marked 2 points A and B. From these 2 points, we have drawn the perpendicular line as well as parallel lines. Then you will get a right triangle. Right triangle here. Then using this right triangle, you will find out the slope. The slope is horizontal distance by vertical distance. It is BC by AC. BC is nothing but S2 minus S1. And AC is nothing but T2 minus T1. Where S2 minus S1 is S, T2 minus T1 is T. We know that S by T is a velocity. S by T is a velocity. Hence, we can say that slope of AB is velocity. Slope of AB is nothing but slope of dt graph. Slope of dt graph gives velocity. This derivation may ask in the examination, please learn this. Similarly, we have another statement with respect to VT graph also. VT graph gives, what does it give?
Acceleration.
Accelerate.
Acceleration.
Acceleration.
Will you try that yourself?
No,
Very good. Lakshmi is ready. Anvekar is ready. Very good. Prajwal SM is ready. Very good. Even Lavanya as well. Okay. But don't go for writing in the notes. Instead, I'll give you the same question in worksheet. What it? In worksheet, you just try to do that regarding slope of VT gives acceleration. Okay. Please do practice.
Yes, sir.
Whatever the concept we have covered today.
sir, S represents speed, sir.
You know what?
Sir, S represents speed.
No. Displacement.
Yes.
Speed ಗೆ ನಾವು V ಅಂತ ತಗೊಳ್ತೀವಿ ಅಲ್ವಾ? S1 and S2 are distances. T1 and T2 are time. Even the acceleration to show that the slope of VT gives acceleration, you can take hint ಕೊಟ್ಬಿಡ್ತೀನಿ. Here you can take initial velocity, here final velocity. Time T1 and T2 will be same. But here in place of distance you will write velocity. Time, it is same one. Can you all do this?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Then, okay, it is time up. Now let me go for concluding. Please try your best. Within 12 o'clock,
Okay,
I
sir.
will give you the worksheet questions. You can
Okay,
try.
sir. Okay,
Yes,
sir.
Yes, sir.
Wait. Last information. This coming Sunday, parent teacher students meeting is there. Please inform your parent. And this coming Sunday, you have weekly test on the chapter motion.
Motion.
What is it? You have weekly test on the chapter motion.
Okay, sir.
Okay.
sir. Okay, sir.
Thank you, sir.
This. Let us stop the class. Thank you very much.
Thank you,